Welcome to Easy Gates Electrical and Electronics Gate Paper Solutions. So we'll begin with the first problem. That's problem number 16 as per the master paper. And before getting into the problem, so overall the electrical and electronics paper is very easy. Okay, so relative to other circuit branches, ECE and instrumentation. A student can easily score around 30 plus in the electrical paper. So we can expect a general cutoff, okay, more than 30. So there are many easy areas to score in the overall paper. Okay, so we'll see them. Okay, when we go through the problems one by one. Okay, so first problem to begin. So that's from analog electronics. An operational amplifier circuit is given. So problem is the steady state output V out of the circuit shown below will be. Okay, will. Okay, so options are given as saturated into plus VDD minus VE or become equal to plus 0.1 or equal to minus 0.1. Okay, so values are not given for R1, R2 and capacitor as well. Okay, so how we can play with this? So no mentioning about the op amp, we can assume op amp is ideal. Okay, assuming op amp is ideal, assuming initially the op amp in linear mode, let us take virtual short VD equal to 0. And assuming no bias current, so this current will be taken as 0 microamps and the voltage at this point will be 0. Therefore, this point will be at virtual ground. Okay, virtual short makes virtual ground, so that is equal to 0 volt. So because of that, the drop across R1 will be so plus minus the whatever the voltage you applied. The bottom is 0. Therefore, this point potential will be 0.1, and this is virtual ground. So the net difference is going to be 0.1 volt. Okay, that is the voltage across your R1s. That is setting the current I. So let the current I is equal to 0.1 volt divided by R1. So that's a current. Assuming once again ideal op amp, there is no input currents. Okay, so at the inverting as well as non-inverting terminal, therefore the entire current I is going to pass from left to right of the feedback capacitor. That is going to charge the capacitor. This is plus and this is minus. That means the capacitor charging is going to be something like this. It's a positive ramp. Okay, so as the voltage across the capacitor increases, so let this is a VC voltage across capacitor, and this you are going to lose from the virtual ground. Therefore, V out is always going to be minus VC of t. But VC of t is a positive ramp. Therefore, V out will be a negative ramp. Okay, so of same slope. Okay, so the slope of this ramp will be, we can determine VC of t is equal to Vc of t is equal to 1 by c integral I of t into dt. Okay, so assuming no initial charge, so let us have the integral from 0 to t, then it is going to be I of t is 0.1 by r1, so it is going to become 0.1 by r1 into c into integration of dt will be t. And this is your slope, 0.1 by r1 c will be the slope, and the slope is going to become negative, that is going to be minus 0.1 volt divided by R1 C will be the slope, and as the time increases, the voltage is falling. So if you allow enough time, so it may saturate the op amp negatively. Okay. So since the current is unidirectional, okay, therefore the op amp will be driven after sufficient time. If you allow for the circuit, or if the circuit is an on condition for sufficient time, it will put the op amp into negative saturation. That potential is marked as minus VEE. So therefore, the best possible answer for this problem is op amp can be driven to saturation, assuming ideal op amp. So that is the answer. Okay, so that is the best possible answer for this problem, but still we can think in another direction, because op amp is not mentioned as ideal op amp. So perceiving the problem in another way, since op amp is not mentioned as ideal, so let me assume there are bias currents as well. So let this is IB1 and this is IB2. There are bias currents for the op amps. So again, assuming virtual ground is not exactly possible here, because it is going to be some potential, call it as Vx, and there is a current in this. So it's going to be IB2. So Vx is equal to minus IB2 into R2. That's a negative potential. So this is also going to be at the same negative potential. So this is also going to be Vx because op-amp will still maintain virtual short. And this is going to be 0.1 and Vx will be negative, assuming, okay, that's the direction of the bias current entering the non-inverting terminal. So this is going to be the potential. It is 0.1 minus what? Vx. Vx is negative. Okay, so there is no virtual ground here now. Okay, so this is positive. So the current is still in this direction. Okay, that current is going to be 0.1 minus Vx divided by R1 will be the current, and there is a current IB1. So this current is I and this current is IB1, and not sure whether I is greater than IB1 or IB1 is greater than I. IB1 greater than I, since it is not mentioned as the ideal op-amp. By assuming ideal op-amp, we can reach the destination of op-amp is driven to negative saturation. So the answer is minus VEE. Suppose if we have a small cross check, so what will happen? We'll see. So if IB1 is greater than I, and to balance the KCL, the current will be down. That is going to charge the capacitor. This is plus, this is minus. That means the capacitor voltage will charge this way. So this is already a negative voltage. So from this negative voltage, you're going to add this, but this current is always in this direction. So that means the potential is going to keep on increasing. So V out is going to become VC plus the Vx, VC plus Vx. Okay, so this VC is going to be a positive ramp. So V out is also going to be a positive ramp, even though it is beginning with the negative potential. So the plot will be something like this. It is beginning with the potential of minus, there is Vx, there is minus IB2 into R2. It is beginning with minus IB2 into R2 negative potential, but the ramp is going like this. That means if you allow a sufficient time, the op-amp will be driven to definitely a positive saturation. So this is only based on the assumption. Okay, it will end to VDD plus VDD. So op-amp will hit positive saturation. That means this is also possible in the given circuit, but such a hint is not mentioned. He didn't say, the designer didn't say we need to consider the bias currents. Okay, but he said he didn't talk about the op-amp. So if you assume practical op-amp, but the problem is the bias currents, still you can go for the answer, but he didn't pass any hint of bias currents. Okay, the practical limitations of the op-amp. If you perceive this way, so it will lead to plus VDD. If you perceive this way, it will lead to minus VEE, but still, so which one can be the best possible answer? If it is MSQ, both A and B are correct. If it is MSQ multiple select question, it is option B as well as option A. Since it is MCQ, so you have to choose the best. Therefore, the best possible answer for this problem is option B. Op-amp will be, assuming ideal op-amp in all aspects, R2 is not coming into play, will put the op-amp into negative saturation under the steady state conditions. So that is a best possible answer. Okay. So we'll update you with the next problem from electrical paper. Okay, so thanks for watching. Okay, so do subscribe our channel and look for the updates. Okay.